Hi everyone, welcome back. Today we are solving maximum level sum of a binary tree. So in this problem, we will be given the root of a binary tree and the level of its roots will be 1 and the level of its children will be 2 and so on. And for each level, we will need to calculate their sum and we want to return the smallest level that the sum of all the values of nodes at that level is the max. So if you look at this example, we will return level 2 because 7 plus 0 has the highest sum out of all the levels in this tree. And in this example, we will return level 2 also because if we look here, level 1 has 989, level 2 has 10,250, and level 3 has a sum that's smaller than level 2, and level 4 has a negative number. So we return level 2. So now that we have seen some examples, let's get to how we can solve this problem. So one way we can solve this problem is we can use breadth first search, and for doing that we will need to set up a queue. So what I will do is I will first set up a queue with the root node inside, and for each level we will add the node's value to the total sum of that level, and then we will pop that node from the queue. And when we look at that node, we want to check if the node has a left value or a right value. If we do, then we need to add that to the queue for the calculation of the future levels. Now after calculating the total sum of each level and adding the left and right values for future levels, before we look at the next levels, we need to check that if the total in that level is the highest total that we have seen so far. And if it is, then we will update the current result to that level. And in the very end, we will return the level with the highest sum. And we will know that we have come to the end if all the leaf nodes or the last level have been popped from the queue. And since the last level will never have a left nor a right, we wouldn't add new nodes to the queue. So that's how we know that we have looked at all the levels, and then we can return the level in the end. So let's go over this example. Q will be the queue and total will be the total sum in the current level that we are on. High will keep track of the highest total that we have seen so far in the layers, which we will initialize as negative infinity. And level will be the current level that we are on, and result will be what we return in the end. And we will update the result every time we see a level with a new high. Now we start with the first layer. So Q will have 1, and now we need to pop this node and add this value to the total, and we also need to add its left and its right, which are right here. Now we see that the total is higher than the high, so we update the high to 1, and since we have a new high, we need to update the result to the level we're on, which is level 1. Now we move to the next level. We have 7 and 0. We will pop these two and get the values, so the total will be 7, and 7 has these two nodes on its left and its right, so we will need to add them to the queue. 0 does not have any, so we just need to pop it and add 0 to total. So now the total is 7, and we have these as our new queue, and total is also higher than high, so we update high to 7 again, and since we have a new high, the new result would be level 2. Now we can move on to the last level. In the last level, 7 plus negative 8 would be negative 1, and it doesn't have children, so we just need to pop these two. Negative 1 is not greater than 7, so we don't need to update the result. And now that we have come to the end, we can return level 2 as our result. So time complexity would be O of n, where n is a number of nodes, because that is the number of nodes that we will iterate through. And the space complexity will also be O of n, because this queue right here can take up to n space. So now let's get to the coding part. So first we will set up the queue with just the top level. So it will have the root node, and the high will be negative infinity initially. We are at level 1, and result will be 0 initially. Now while Q total set to 0, now we will loop through that level. We will pop the node, so Q.pop left. We will add the node's value to the total. Now if the node has a left value, we will append it to Q, and we will do the same with the right side of the node. So node.right, Q.append node.right if node.right. Now after that level, if the total is higher than the current high, then we need to update the result to that level and set the high to that total and increment the level by 1 as we enter into the next level. And finally, we can return result. See if it works. Okay, perfect. Hope this was helpful. Thank you all for watching. If you have any other questions or comments, feel free to leave them in the comment section, and I hope to see you all again soon.